The formatter is designed to be programmed directly from the user's Laboratory Information Management System, the LIMS. Watson is the predominant LIMS, however other spreadsheet formats may be used. By programming the formatter directly from the LIMS, there can be no misinterpretation of the data. The incoming LIMS work list is loaded on the formatter computer at Tomtec formatter /real/data/worklist/imported. The incoming file must be in the .csv file format. It may be opened with OpenOffice, which is supplied with the formatter. Open in the tab delimited format. The imported work list may then be called up under Import Work List, then imported. For this example, use LIMS Extended Work List Sample and Open. The first step is to select the correct deck layout for this program. Previously saved layouts may be called up or a new layout created. The layout provides the mechanical dimensions of the microplates, racks, and vials that are to be used for the program. These selections are made from the data that resides in the formatter container database. After selecting or creating the deck layout, click Next. This brings up the program setup screen. Since this is a new program, select New Setup and click Next. This brings up the LIMS work list. The first entry required is the number of lines that must be skipped to arrive at the first data line. In this example, it is 30. This is entered into the box provided. Next, enter the column that contains the ID data, in this case, column A. Then the dilution factor, which is in column M. If barcodes are used, that column is entered. In this example, the barcodes are not used. Click Next to proceed. The formatter software endeavors to interpret the LIMS for sample type. This may not be correct in all cases. The operator is asked to verify the sample type. Unknowns are all treated as single samples. On the standards, QC, and blanks, if the same designation is applied, they will be treated as replicates. In this example, click the first line as Standard 1. This type agrees with the ID. The highlighted line indexes. Clicking Standard 2 assigns Standard 2 to the second line. This proceeds through Standard 11, assigning a specific type to agree with the ID. Blank 1 is used for the control blank. QC1 is assigned to the QC low, QC2 is assigned to QC medium, and QC3 is assigned to QC high. Control blank is a replicate, so blank 1 is assigned to this line. This continues through the entire work list. If 2 or more samples have the same type name, they will be treated as replicates. One cryovial is opened and it is accessed with the same tip for all replicates. A single name implies a single source and a single destination. The exception are those samples marked unknown. They are all treated as single samples. The other category may be used to designate different types not listed elsewhere. Other is used in the same manner as all of the other type designations. It simply provides a catch-all type category. After assigning the correct type to all samples, click Next to proceed to the next step. The next step assigns source and destination information to each sample type. Click Source and Standards. You must tell the formatter where you are placing the samples. If you're not using barcodes, you must identify each sample with its source location. Assume you're going to put the standards in the Q rack. Click Q, define the starting location for standard 1 as QA1. Then, define if the consecutive numbers are to run horizontally in the Q rack or vertically. In this case, select vertically. Standard 2 must be placed in QB1, Standard 3 in QC1, and so forth. However, in this deck layout, a 4x8 rack was used for the Q rack. Thus, Standard 1 through Standard 8 can go in the QA1 through QH1. However, Standard 9, Standard 10, and Standard 11 must go in the next row, QA2, QB2, and QC2. Having defined the source location for the standards, next select the pipetting template that is to be used for these samples. In this case, aspirate standards. Repeat this operation for the QC samples. Since 2 rows of the Q rack, 1 and 2, were used for the standards, select the Q rack and row 3, QA3 for the QC samples. For example, QA3, QB3, QC3, QD3. Again, select the desired pipetting template for the QC samples. In this example, aspirate standards. Again, remember, if you are running by position, you must put the correct sample in the position you have identified. The next type is blanks. Here there are some special options to consider. If all of the blanks are the same, for example, blank plasma, then a single reservoir choice may be made, for example, RA1. However, there may be several types of blanks, for example, blank with drug, blank with internal standard, in addition to just blank plasma. These may be identified as blank 1, blank 2, blank 3, etc. The same as with standards and QCs. Bear in mind, each container, cryovial, must have a sufficient volume for those samples. Having assigned the source location for the blanks, next assign the template, in this example, blank plasma. The unknowns commonly come from the S rack. As before, a starting location is selected, and the direction or order is defined for the rest. However, notice that this work list has a total of 191 samples. This is an extended work list requiring 2 microplates for the destination. The formatter is designed to handle extended work list with the following limitations. The destinations may not exceed 2 96-well plates. Only the S rack of unknowns can be increased from 1 to 2 racks. All other samples, such as standard, QC, blank, and others, must be accommodated by space on the deck or in the Q rack. Only the S rack for unknowns can be increased from 1 to 2 racks. The start location is designated in both the first rack and in the extended rack. The order of processing, vertically or horizontally, is defined and is the same for both S racks, start and extended. Again, the pipetting template is assigned for the unknowns. Other is used in the same manner as all of the other type designations. Clicking on Others enables defining those types of samples both as to deck location and pipetting template to be used. In this example, others are not used. The last source to be defined is diluent. This defines the source location and pipetting template that is to be used to add diluent to all incoming samples that require dilution. These are shown in the dilution factor column. Normally, the diluent comes from a reservoir, since a significant volume of diluent may be required. Only one source location can be designated. That source must have sufficient volume for all of the diluent requirements. In this example, blank plasma. This completes defining the source location and pipetting templates for all incoming samples. If barcodes are not used, then each sample must be placed in its designated location by the operator. Position is the only cross-reference between the actual sample and its designation on the limbs.